Hey everybody, this is Mr. Anders with a video about how to solve quadratic equations by graphing. Starting today, you're going to start solving quadratic equations, and you're going to be doing that for a little bit here. All right, so the first technique we're going to use is how to solve by graphing. Now, before we do that, um, let's think about how have you solved equations in the past. So let's just take an equation like this, 2x plus 7 equals 15. How do you get x by itself? Well, how you probably were taught is to undo the operations being done to x in some manner or another. So you would first take away 7, and then you'd have 2x equals 8, and then you divide both sides by 2, and you get x equals 4. All right, so that's how you've been taught to solve equations in the past, most likely, where you undo operations. Now, can you use the same technique to solve something like this? X squared plus 5x plus 3 equals 17. Let's give it a shot and just see what happens here. So I'm going to go ahead and looks like maybe I'd take away 3 first. Let me try that. Okay, looks like that's going to do something here. All right, so I have x squared plus 5x equals 14. Right here, though, like it's kind of like, what do you do next? Do you take away 5x from both sides? If you did that, you'd have like a minus 5x over here, and then you'd have x on both sides. You have an x squared over here and a minus 5x over here, right? Like this. So that's not going to work out so well because now you have x's on both sides. You want to try to get x on one side and your constants or your plain numbers on the other. There's basically no way to do that with this kind of quadratic. You might see a type of quadratic soon where you can do that, but um, not all quadratics can be solved by getting the variable by itself, unfortunately. So what you learn to do with these kind of equations, these were called linear equations, by the way, you cannot always do the same thing for quadratic equations. There's different methods of how you can solve quadratic equations. The first one, like I said, we're going to talk about is graphing. So let's go ahead and take an equation here and solve this by graphing. So first thing you want to do is get all terms to one side. Now you do that by just uh, doing whatever you need to do to you want to look at the side that has the least amount of terms usually. So looking at the 8. Well, I can get that over to this side really easily by subtracting 8. So this is going to kind of at first seem a little weird because you're used to getting, numbers on one side and variables on the other. But with quadratics, generally getting everything to one side is what you want to do first. Okay, so what we end up with here is this. Now notice I put the minus 8 underneath here, but it can't combine with that, right? This has an x in it, this doesn't. You can't combine those together. So you just write it all, side by side here. X squared minus 2x minus 8. You just write it out like that. Okay, so we have that now. Then what you do, at least with the graphing technique that we're learning about today, is you write the related function. So right now, this is not a function. This just has x in it. There's no y here. You only have a function when you have at least two variables, right? Usually x and y, or x and f of x. Right now, we just have one variable. We're actually going to take this side here and make it into a function, and then just, uh, you know, set it equal to f of x. You can make this whatever you want, but let's just keep it simple and we'll call it f of x, all right? So now we've made a function out of this, right? You have an x variable, and then this is basically your y variable. Now, if you think about, if you compare these two equations, what did f of x take the place of? It looks a little different up here. It's a little flip-flopped, but what did f of x take the place of? Well, really, it took the place of 0. And if you think about what we're asking here, this equation here is asking, hey, when does this equal zero? Like what values of x could I put in here to get this side equal to that side, which that side's zero. So how can I make this zero? So I'm kind of thinking ahead here. What we're going to be interested in is when is this zero? When is f of x zero? Okay, and that's going to give us the answer. It's going to give us, what values of x make it zero. When I say when is f of x zero, I mean like what values of x make f of x equal to zero. So we could do that a lot of different ways, but again, today we're going to focus on graphing. So how do you see on a graph when f of x equals zero? Well, again, just remember f of x is basically another name for y. So we're going to be looking at the graph and see where does y equal zero. So let me go ahead and we're actually going to put this into Desmos now. All right, to get to Desmos.com, actually, before we do that, quick plug for Google and their coding. They have this coding app going on right now, so you could click this and do their little coding game. Kind of cool. All right, but yeah, to get to Desmos.com, you just go to Desmos.com. Now yours probably won't have the slash calculator come up first. So just go to Desmos.com, not student.desmos.com, just regular Desmos.com. Hit enter. Then you're going to click start graphing, and that puts the little slash calculator in there. There we go. That's how you get to Desmos. Let me put this function that this what we call the related function into Desmos. So if it's been a while since you've used Desmos, let me go back for just a second. If you want to put in an exponent of 2, actually, you've probably been using the caret. You could do that. Okay, if you hit caret, that's what happens. Okay, but also if that's a little weird for it, you can go down here and just click a squared, and that'll just make that whatever variable you have there squared, and then minus 2x minus 8. Okay, so the question is, where on the graph is y equals 0? Think about that. Where on the graph does y equal 0? Okay, is it here? Is it here? Is it here? Yeah, where does it equal 0? Well, yeah, on the x-axis, right? This is a y value of 0. It's neither up nor down from the middle of the graph. So where the graph equals 0, or I should say, the values of x that make y, or f of x equals 0, are negative 2 and 4. Okay, so going back to my paper now, I'm going to write that down. So yeah, x equals negative 2 and x equals 4. All right. Um, so one thing you're going to see in the assignment also, these are the answers to our original equation. Like this, so basically what makes this true, the values of x that make this true are negative 2 and 4. You can try it out. You can put negative 2 in here. Does this come out to 0? It would. Okay, I'm not going to spend the time to do that, but you can do that yourself. And same thing with 4. Oftentimes, what these are called, not only are they're the answer to this equation, they're also called the zeros. Okay, that's one way to spell zeros there. Um, so they are the zeros of this function here. Okay, so just a little language we got to watch out for here when we're talking about functions. The values of x that make it 0, they're called zeros. Now, when we're talking about just a plain equation, a one variable equation, these are the solutions or the answers to this equation. All right, so you're going to see that in the assignment. So let me go ahead and show you a problem on HRW. All right, so this question 1 here says solve the quadratic equation by selecting the graph of its related function and finding its zeros. So we're going to have to create the related function and then select the graph. And then we're going to have to say what the zeros are and the answers are, which you might be like, whoa, that's a lot of information. But you'll see There's a lot that is the same when we get there. All right, so let me I'm going to write this down on my paper here. Oops. So 2x squared minus 141 equals negative 43. Yeah, I would definitely recommend you do this homework with some paper and pencil at hand. All right, so the related function. In order to get that, what you do, put this as number one here. Your number one, of course, might look different, right? My.hrw.com generates these fresh every time, so yours might not look this way, but it's going to be a similar technique. So yeah, to get the related function, you want to um, have one side equal 0 or get all the terms to one side. So what I'm going to do is add 43 to both sides. Okay, so that gets everything to one side and then 0 on the other. Let's say that's going to be 98, negative 98. Okay. All right, so now what you could do here is just, step two from my original notes were to make this into a function. All you do is you just say, hey, this equals f of x. And now go ahead and graph that and see where well, here, let's write in our answer, first of all, our first answer. So we could put 98 here. They already have the minus in here for us, so we just put 98 right here. Okay, all right. They already have the 2x squared there also, so we just have to kind of finish it off. Okay, now we have to select which graph is the correct one. Well, let's go over to Desmos and graph this. So get rid of that, and f of x equals 2x squared minus 98. All right, so one thing that might help when you do it on Desmos, if you click down on the points here, they stay there, and that's actually going to be one of our later answers. That'll kind of help us narrow down the options. Whoops, they went away. There we go. So let me go over to our problem again. So we can eliminate this one because this says negative 7, 1 and 7, 1. It's not going to go through there. Yeah, it's where if it were y value of 1, it'd be a little bit off there. So no, definitely not that one, nor this one. It doesn't hit 7, negative 1. It hits 7, 0. So it's got to be one of these bottom two. And then pretty much we can eliminate the one. This is concave up. We don't see the whole parabola here, but it is concave up. So we know it's got to be the concave up one. Now you might get some problems though where you still have to do some more narrowing down. You could see where the y-intercept is, and so that would help. And that should do it. That should narrow it down. So it is definitely C here. And then it says the zeros of the related function are blank and blank. Well, those are the values of x that make the y value come out to 0. So that's negative 7 and 7. So let me go put that in, negative 7 and 7. And that means the answers to the original equation, what our x equals in our original equation, are those same two numbers. Okay, so it's just always going to be, that's the same as this is the same as this. The order doesn't matter, by the way. I could have done 7 and negative 7. I don't think HRW complains about that, but I could be wrong about that. I wouldn't think, the order should not matter there. So I'll check my answer. Yay, I'm right. Okay, so that's how that works. Let's take a quick look at problem like number 3. So here we have 11x plus 18 equals negative x squared. So this looks a little different than what we saw in number 1 here. So let's write that down though, and we're going to approach it very similar way. Um, so we want to get everything to one side. So I'm going to actually add x squared to both sides. And once again, this cannot combine with anything here. Yes, these both have x in them, but just remember the rules around that. If you have different exponents, this has an exponent of 2, this has an invisible exponent of 1, you can't combine those together. So I'm going to write it out in this order, which that's the reason I'm doing that It wouldn't be the end of the world if you didn't, but I like to see it in standard form. So if you've noticed with standard form, you have the quadratic or the squared term first, and then you have the term that has an exponent of 1, or just the plain x term, I call it sometimes, and then your constant or your plain number at the end. All right, so we have that, and now you would just do the rest just like number 1. You would make a function that looks like the left-hand side of that, and then you'd graph it and find the zero. So I'm not going to do the rest, but just wanted to bring that up. Let's also do a word problem also. So let's take a look at number 5. It says to create a quadratic equation for the given problem and then solve the equation with a related function using a graphing calculator. We're going to be using Desmos. You don't need a graphing calculator. If necessary, round your answer to the nearest hundredth. So it says a ball is dropped 11 feet from the ground, or above the ground rather. The function h of t equals negative 16t squared plus 11, where t represents the time in seconds, gives the height in feet of the ball above the ground. When will the ball be 5 feet above the ground? So let's translate this into math. What can we do? What can we write down on our paper to sort of solve this? So let me just write down the function first of all. And if you think about what it's asking us here, well, one piece of information we don't have to worry about at all. This 11 here, that's already in the equation. Sorry, my phone's making noise here. That's already in the equation. So we don't have to worry about this 11 feet. It's already there. But it does say, when will the ball be 5 feet above the ground? If you think about what this equation means, this here, this represents the height, and it gives us a height here. It says 5 feet. When will it be 5 feet above the ground? So we actually put the 5 in for h of t here. We're asking the equation in a way, hey, when, what value of t, how long will it take for the height to be 5 feet? And now we solve this just like you've done the previous problems. We're going to get everything to one side. It's going to be easier to take away the 5 here on both sides. And so I get 0 equals, now these do combine, right? Well, here, let me bring down the negative 16t squared. 11 minus 5 is 6. So we get this equation, negative 16t squared plus 6. And then I do need to write the related function here, just like you did on the previous problems. I think Desmos doesn't like t. I could be wrong about that, but I'm going to go ahead and change it to x just in case. So I just changed, yes. So, make this new a function, right? So here now it's a function, and I just rewrote it, changing t to x. Okay, let's go ahead and put that into Desmos now. And then we're going to put in that related function, f of x equals negative 16x squared plus 6. And so what we're looking for is what the zeros are, okay? And there they are. And we don't get, great numbers here. They're rounded, they're decimals here. And really only one of them makes sense. If you think about the original problem, it said the ball will be 5 feet above the ground after about blank seconds. Negative time doesn't make sense here. So we just ignore that 0, okay, or that answer. We just use the positive one. So we would put in, and it said round to the nearest hundredth, all right? So that would be 2 decimal places. My.hrw is .com is very picky if you're using that. Maybe your teacher is using a different platform here, but if you're using this website, make sure you actually do round to the nearest hundredth. So I'm going 0.61. We would not round up because this 2 is less than 5. All right, and let's check our answer here. Awesome, we got it. Okay, so that's how that works. If you guys have any questions about these problems, please email your teacher. Do not be shy. Your teacher would love to hear from you. So feel free to email them. It's probably the best way. I've also had some of my students make comments on the Google Classroom assignments, that works too. That goes straight to our email.